Okay, students, so we're here and we're going to be doing converse of all the theorems that we've been talking about. So remember, a converse of a statement is when you swap the order. All right, so that's the punchline of today, the converse of the theorems. And remember, the converse is swapping the order of the hypothesis and conclusion. All right, before we even start diving into the converse of the theorems we've been talking about, let's just review some things about converses itself. All right, so write the converse of the following statement. If two lines are perpendicular, then they intersect to form right angles. Okay, so two lines are perpendicular, intersect to form right angles. All right, so remember, we just don't blindly swap the hypothesis and conclusion. We try to make it sound grammatically correct. So if two lines intersect, then intersect to form right angles, then they are perpendicular. All right, so recall, intersecting to form a right angle went up front, became the hypothesis, are perpendicular, became the conclusion. So that's it. That's the converse of a statement. All right. Are the converse of true statements always true? Well, reminder, the answer is no. They don't have to be true. In this particular case, is the conditional statement true? Yes. If two lines are perpendicular, they do form right angles. Again, perpendicular lines, boom, they intersect to form a right angle. And then if two lines intersect to form right angles, then they are perpendicular. So the converse in this case is true as well. And remember, when two things are, when the conditional is true and the converse is true, all forms are true. So then you could write it by conditional statement. All right, so that's just a little review of converse. Let's dive into things now. All right, we got the parallel line converse, corresponding angles converse, cap converse. Okay. Corresponding angles converse. So if two lines are cut by a transversal and a pair of corresponding angles are congruent, then the lines are parallel. All right, so it's literally switching what we had before. The punchline, or the hypothesis was if two lines are parallel. That's how they all started. The lines had to be parallel for all those theorems to be true. Now we're going to say, well, what if angles are congruent? What does that make the lines? And in fact, they're parallel. Okay, so what does that mean? So let's draw an example. It's saying if so let's just draw this. I'm going to call this angle 1 and 2. I'm going to be really creative. So if angle 1 is congruent to angle 2, then we'll call that line A and line B, then that's going to force the lines to be parallel. That's the cap converse. So then the lines are parallel. So before we said if the lines are parallel, corresponding angles are congruent. Now we're saying if corresponding angles are congruent, then the lines are parallel. All right, so literally just swapping the order. Cool, cool, cool. And this is going to really help us in the future with some other shapes. Alternate interior angles converse, the AIA parallel converse. If two lines are cut by a transversal and a pair of alternate interior angles are congruent, then the lines are parallel. So again, what does this mean? We're saying if, I should just copy and paste from above, but I'm just going to draw it again. I'm really good at drawing anyways. You guys enjoy watching me draw probably. I'm a very good artist. Okay, now we're going to say, call that angle 1 and 2 again. If angle 1 is congruent to angle 2, then the lines are parallel. All right, that's another way. And in my humble opinion too, what do we see the most in the future? What do we talk about the most is alternate interior angles. I like all of these. Alternate interior angles is probably the most important. Consecutive interior angles we do use here and there. Corresponding angles come up occasionally. But I would say the most important ones are the alternate interior angles. All right, and again, you probably can figure out the remaining boxes. Alternate exterior angles converse, the AEA parallel converse. If two lines are cut by a transversal and a pair of alternate exterior angles are congruent, then the lines are parallel. And let's be a little lazy, I guess. We don't have to redraw this thing every single time. I'm going to copy. I'm going to paste. Probably should change the color. Let me change it to, that would probably look pretty. Ooh, very pretty. Okay. Next, let's eliminate the interior angles. Say that's 1, that's 2. So in this case right here, we're saying if a pair of alternate exterior angles are congruent, then the lines are parallel. All right. And why do we like parallel lines so much? Well, parallel lines are just important. You want both sides of the roads to be parallel, because if they intersected, then the cars would hit each other. Or you want the floor and the ceiling of a building to be parallel. If they aren't, then the building's not constructed that well and it would fall over. All right, so that's one of the reasons why we're talking about parallel so much. And it's really going to help us in coordinate geometry later. All right, consecutive interior angles converse, CIA parallel converse. If two lines are cut by a transversal and a pair of, ooh, I don't like that gray. Let me pick a different color. Consecutive interior angles are supplementary, then the lines are parallel. All right, let's paste that again. How do I paste? I think I gotta click text. No, oops. Scissors maybe. Paste, there we go. All right, let's change the color. Let's see what like electric pink looks like. Electric pink would be that. Ooh, that looks very pretty. Okay, so then we got a little erasing to do. So this is saying if the measure of angle 1 plus the measure of angle 2 equals 180 degrees, then the lines are parallel. In fact, I think I forgot to change my 1 and 2 up there. Oops. That should be angle 1 and angle 2 up there. All right, so that's just the converse of the theorems. All right, literally swapping the punch lines, all right? So how are these theorems different than the theorems that we used earlier in this unit? So I'm going to have to explain this a lot. This is a huge punchline. Students like to get confused. Theorems, this is how they are. If parallel, then angle relationships. All right, typically congruent, but there is the one that's supplementary. So if lines are parallel, then we have the angle relationships, whether it's congruent or supplementary. That's the theorems. The converse, say if angle relationships, then parallel. All right, and even again, oversimplifying again, theorems prove the angles are congruent or supplementary, but I just wrote congruent for this particular case. So it's saying if these lines are parallel, 1 and 8 are congruent. But the converse proves that lines are parallel. If 1 and 8 are congruent, then the lines must be parallel. All right, that's it. Very tedious, very intricate, easy to get confused. But when you're proving lines are parallel, you're going to be using the converse. So let's even write that. Proving lines parallel, use the converse. All right, that's it for this video. We'll continue in the next one.